Did you feel it? One of the biggest earthquakes in Texas history was just felt in San Antonio.
In a state known more for its oil fields and wide open spaces, an unprecedented force of nature has shattered the calm. About a month ago, the strongest earthquake ever recorded in Texan history struck with a fury no one was prepared for.
Texas becoming so persistent that homeowners there say they can't repair their homes fast enough. They say the violent tremors are happening almost daily now.
It was a seismic event so powerful, it sent shockwaves not just through the earth, but through the scientific community as well. What shocking discovery have scientists recently uncovered beneath the Texas soil that has sent them running? And what secrets are the authorities desperate to keep under wraps? Join us as we uncover the heart-stopping details of how scientists scrambled to evacuate Texas after the strongest earthquake ever hit the oil-rich state. Texas's earthquake surge. For much of its history, Texas was thought to be an earthquake-free zone, situated far from major tectonic plate boundaries like California's San Andreas Fault, where big and frequent quakes are common. Texas saw very few seismic events. When earthquakes did occur, they were minor and often went unnoticed. The first recorded quake in Texas happened in 1847 near Seguin, but it was so small that it caused no real damage. Through the 19th and 20th centuries, the state's seismic activity remained low, with most quakes being minor and rare. The biggest quake before recent times was the 1931 Valentine earthquake, which, at magnitude 6.0, was the largest Texas had ever experienced. It caused some damage in Valentine, a small West Texas town, but remained an isolated event. In the early 2000s, residents in areas like North and West Texas began noticing a rise in small earthquakes. The surge in seismic activity, especially since 2008, puzzled and worried many. Before 2008, Texas had only a few dozen minor earthquakes, but after that, the state experienced a significant increase, especially in places like the Dallas-Fort Worth Metroplex, the Permian Basin, and the Eagle Ford Shale. One of the most notable quakes in recent Texas history struck on May 17, 2012 near Timpson in East Texas. With a magnitude of 4.8, it was felt over a large area, including parts of Louisiana. This quake was significant because it was one of the strongest Texas had seen in decades, and was directly linked to nearby wastewater injection wells. Residents reported minor damage to homes and buildings, prompting investigations into how wastewater disposal might cause earthquakes. The Timpson quake is a key example of the risks associated with wastewater injection. Another major quake occurred on March 26, 2020, near Mentone in West Texas. Measuring 5.0 in magnitude, it was one of the strongest quakes in Texas history. Felt across West Texas and even into New Mexico, the Mentone quake happened in the Permian Basin, a region known for extensive oil and gas production. Like the Timpson quake, it was linked to nearby wastewater injection wells, further highlighting the seismic risks in areas with heavy oil and gas activity. Between 2021 and 2024, Texas experienced a dramatic rise in both the number and strength of earthquakes. According to the Texas Seismological Bureau, the state was shaken by over 2,000 earthquakes of magnitude 2.0 or higher during these years. This was a significant jump from the 1,600 quakes recorded in the previous 4 years. Many of these quakes were strong, measuring 4.0 or more, leading to damage in key areas, especially in the Permian Basin, a major center for oil and gas production. One of the most notable events happened on December 21, 2023, when a powerful magnitude 5.4 earthquake hit near Midland, Texas. This quake was felt widely across West Texas and caused extensive damage to buildings, roads, and pipelines, illustrating the growing seismic activity and its impact on the region. A rare tremor hits West Texas. In West Texas, July 26, 2024, started off like any other typical Friday morning, but by 9:30 a.m., everything changed extraordinarily. A massive rumble shook the entire area, registering a powerful 5.1 on the Richter scale. This earthquake was the strongest ever recorded in this part of Texas. The quaint town of Hermel, located about 200 miles west of Fort Worth and close to the epicenter, experienced the full force of the quake. Normally a peaceful place where life moves slowly, Hermel was suddenly jolted into chaos. The tremors were so intense that people felt them far beyond the town, reaching North Texas and Dallas, among other distant areas. Buildings swayed, and items toppled off shelves, creating a cacophony of noise. This was not an isolated event. In the days leading up to this major quake, the region had been experiencing a series of smaller tremors, which left residents increasingly on edge. Earlier in the week, a 4.9 magnitude quake had struck, and the day before, a 2.5 magnitude tremor had rattled the area. These smaller quakes were like warning signs for the big one that hit on Friday morning. For many locals, the series of quakes was both shocking and unsettling, as West Texas is not typically known for seismic activity. The science behind the earthquake is intriguing. The U.S. Geological Survey, USGS, uses advanced technology to monitor seismic activity, measuring the magnitude of earthquakes with the Richter scale. A magnitude of 5.1 is significant, especially for an area like West Texas, where earthquakes are rare. This event serves as a stark reminder that the Earth is always shifting beneath our feet, and when it moves, it can be quite surprising. In the aftermath of the quake, Hermely and the surrounding areas faced a wave of structural damage. Homes suffered broken windows, falling objects, and cracked walls. Older buildings, not built to withstand such seismic events, were particularly hard hit. San Angelo shaken. In San Angelo, residents felt the earth tremble as the shockwaves from the earthquake reached their city. It wasn't just a small rumble either. This quake's impact was widespread, shaking areas far beyond the actual epicenter. The city's officials are now on high alert, quickly assessing any potential damage to buildings and infrastructure to ensure everything remains safe and sound. This earthquake, measuring a strong 5.1 on the Richter scale, struck not long after a 4.9 magnitude quake hit Rotan just days earlier. These back-to-back tremors have everyone in West Texas on edge, sparking concern about the shifting geological conditions beneath the region. With these recent events, local authorities have ramped up their monitoring systems, ensuring the community is prepared for anything the future might throw their way. What made this earthquake especially noticeable was how shallow it was, only about 1.1 mile deep. Shallow quakes are notorious for causing intense surface shaking, and that's exactly what happened here. Even towns farther away, like Leck and San Angelo, were rattled by the vibrations, which felt much stronger than what you'd expect from a distant quake. For many in the area, this quake was an unforgettable experience. Take Abby Hagar, for instance. She grew up in California, where earthquakes are a regular part of life, but this one in Texas felt different. Instead of the slow rolling sensation she was used to, this tremor hit suddenly and sharply. Local authorities wasted no time in responding. Scurry County officials declared a disaster, and emergency teams immediately sprang into action. They focused on everything from checking buildings for damage to assisting residents. They wanted to make sure that nothing was overlooked and that everyone stayed safe. This earthquake had the full attention of scientists and specialists too. Brian Stump, a seismologist from Southern Methodist University, highlighted just how unusual this quake was for West Texas. While magnitude 5 earthquakes aren't rare across the country, they are not typical for this part of Texas. This tremor is part of a rare series of quakes in the region, and now everyone's asking the same question: what's causing these earthquakes? Texas has been proactive about monitoring earthquakes like this one. The state's advanced seismic monitoring system is constantly gathering data from stations spread out across the region. These stations are equipped with sensitive instruments that can detect even the slightest movements. After an earthquake, scientists pore over this data to better understand the event, everything from how powerful it was to how deep it struck and where exactly it originated. These efforts are critical in a region like West Texas, where earthquakes have been rare but are now becoming more frequent. Swift emergency response. In the wake of the earthquake, the Texas Department of Emergency Management, TDEM, sprang into action, playing a crucial role in guiding local governments and emergency teams. Thanks to the data from the state's earthquake monitoring network, TexNet, TDEM, was able to provide up-to-the-minute seismic information. This real-time data was essential for assessing the earthquake's impact and deciding on the best response strategies. With TexNet's insights, officials quickly understood the quake's strength and made informed decisions about keeping the public safe and managing the emergency. After the initial quake, TexNet didn't just stop there. It continued to track aftershocks and evaluate the chances of more seismic activity. This ongoing monitoring was vital for keeping both the public and local authorities updated, ensuring they could stay safe and prepared. TDEM, working closely with local emergency teams, sent out crucial alerts and safety tips to the community. These updates included instructions on staying indoors and taking cover under sturdy furniture to protect against aftershocks. Clear, straightforward communication was key to easing public concerns and ensuring everyone knew how to stay safe. Officials urged residents to assemble emergency kits and develop family emergency plans. These kits typically include essentials like water, non-perishable food, flashlights, batteries, and first aid supplies. Having a family emergency plan helps everyone know exactly what to do and where to go if another earthquake strikes. Local governments and emergency teams also organized outreach efforts to boost earthquake preparedness. This education is crucial in a state where major quakes are rare but could still pose a serious threat. Public service announcements, educational booklets, and workshops were some of the ways they raised awareness and readiness among residents. Scientists from top institutions like the U.S. Geological Survey, USGS, and the Texas Seismological Center also jumped into action, racing to understand the situation. Their mission was clear: gather as much information as possible about the recent surge in seismic activity. They meticulously monitored the frequency and strength of aftershocks, studied the depth of the earthquake, and analyzed the fault line that had shifted. This information was crucial not only to make sense of the current event, but also to enhance predictive models for future quakes in Texas. Meanwhile, the Texas Railroad Commission began investigating the alarming spike in earthquakes. Over the previous week alone, more than 100 tremors shook West Texas, many in areas not usually linked to major seismic events. The unpredictable and complex nature of the terrain added to the challenge. Texas, known more for its vast plains than earthquake threats, wasn't built to handle powerful quakes. Most buildings and infrastructure lacked earthquake-resistant design, leaving scientists to grapple with a dangerous and unfamiliar environment. This made their job even more urgent as they worked to mitigate risks and uncover the reasons behind this unexpected seismic storm. The tremor was strong enough to be felt and definitely caused some worry, but it didn't do enough damage to trigger a large-scale evacuation. Local TV news gave an update a few days after the quake on the damage and rising concerns. While most buildings held up just fine, a few areas weren't so lucky. Some evacuations took place in spots where buildings were at risk, or where the threat of aftershocks loomed. Thankfully, these evacuations were mostly precautionary and involved only a small group of residents and workers near the quake's epicenter. Unfortunately, some of the news didn't get it quite right. A few media outlets mistakenly claimed entire towns were being evacuated. But that wasn't the case. This misinformation likely came from the initial chaos and the speed at which things spread on social media, where the situation was blown out of proportion. In reality, the evacuations were small and done with safety in mind. Local authorities and emergency crews responded quickly, assessing the risks carefully. Their decision to evacuate was based on the need to keep people safe, not because there was a massive threat. Fracking and earthquakes. The connection between hydraulic fracturing, better known as fracking, and earthquakes has sparked heated debates among scientists and everyday people alike. With the recent magnitude earthquake in Texas, conversations about whether fracking could be responsible for the rise in earthquakes in areas not typically prone to them have reignited with fresh intensity. Fracking works by injecting fluids at high pressure deep into the Earth's crust to break apart rock formations and release oil and natural gas. This method, however, can sometimes set off earthquakes. When the injected fluids seep into fault lines, they alter the pressure, causing these faults to slip and create tremors. These events, known as induced seismicity, are usually weaker than naturally occurring earthquakes. Yet, there have been occasions where fracking or related practices like wastewater injection have been tied to stronger quakes. In Texas, the number of earthquakes has skyrocketed, 10 times more now than just a few years ago. As part of drilling operations, companies pump huge amounts of wastewater underground into injection wells. The science behind these induced earthquakes is complex, and while most experts agree that fracking can cause seismic activity, we are still figuring out the exact conditions that make this happen. Research by the USGS reveals that when fluids are injected deep underground, they can raise the pressure within fault zones, reducing the friction that normally keeps these faults locked in place. When this pressure gets high enough, the fault may slip, triggering an earthquake. Still, it's worth mentioning that not every fracking operation causes earthquakes. Whether or not a quake occurs depends on factors like how much fluid is injected, how fast it's done, the region's geology, and how close the operation is to existing fault lines. Texas is a prime example of this complexity. Its geology is complicated, and while there have been cases of fracking-induced earthquakes, they're relatively rare compared to the thousands of fracking operations that take place each year. Supporters of fracking argue that when done properly, under strict regulations and with careful monitoring, it's a safe process. They highlight how fracking has boosted Texas's economy, creating jobs, increasing energy independence, and bringing in revenue for local communities. They also point out that most fracking-related quakes are small and don't pose significant risks to people. On the flip side, critics argue that the risks, including induced earthquakes, water contamination, and environmental harm, are too great to ignore. They call for tighter regulations, better monitoring, and in some cases, a halt to fracking in earthquake-prone areas. The recent earthquake in Texas has given a big boost to the argument that there might be a link between fracking and earthquakes. This event has sparked louder calls for deeper scientific research into the connection between the two. As a result, several states, including Texas, are taking action to reduce the dangers tied to fracking. The Texas Railroad Commission, which oversees oil and gas activities, is now diving deeper into the issue, particularly looking at how companies dispose of the wastewater left over from fracking. To tackle the problem, new rules have been put in place. These include limits on how much fluid can be injected into the ground and at what speed, along with the need to monitor seismic activity around fracking areas. But there's still debate over whether these rules are enough, with some experts pushing for even more thorough strategies to handle the risks of man-made earthquakes. To get a clearer picture of the potential link between fracking and earthquakes in Texas, it's useful to look at the history of fracking-related quakes, not just in Texas, but also in places like Oklahoma. Texas has long been a leader in oil and gas production, especially since fracking took off in the early 2000s. But it wasn't until the past 10 years or so that people really started worrying about the possibility of fracking causing earthquakes. Texas may sit right in the middle of the North American tectonic plate, far from the more active earthquake zones along the plate boundaries. But that hasn't kept the ground from shaking. Over the years, the rise in fracking and activities like wastewater injection has brought with it a surprising surge in small to moderate earthquakes in parts of the state. In areas like Dallas-Fort Worth and the Permian Basin, where tremors used to be rare, they're becoming more common. One of the earliest major instances of what experts believe could be fracking-induced earthquakes hit in 2008. A series of small quakes rippled through the Dallas-Fort Worth area, an unusual occurrence, and they happened near sites where wastewater was being injected deep into the ground. Scientists from the U.S. Geological Survey and other research groups dug into the matter and found that the practice of injecting fluids into underground formations likely triggered these earthquakes. In the years that followed, Texas experienced a notable increase in seismic activity, raising alarm bells about the connection between fracking and these quakes. In 2012, for example, a powerful 4.8 magnitude earthquake rocked the town of Timpson, Texas, and this quake, too, was linked to nearby wastewater injection. This became one of the largest suspected cases of man-made earthquakes in the state. As similar incidents cropped up across Texas, the call for stricter regulations on fracking and wastewater disposal grew louder. Now it's time for today's subscriber pick. In the heart of Texas, a small team of scientists was engrossed in their groundbreaking research on seismic activity. Nestled in the quiet town of San Angelo, their state-of-the-art lab was a hub of excitement and anticipation. For months, they had been monitoring unusual tremors beneath the Earth's crust, believing they were on the brink of a major discovery. One chilly autumn morning, the readings took a dramatic turn. The seismic sensors began to blare with intensity, signaling an unprecedented shift. The team's lead scientist, Dr. Anna Brown, examined the data with wide eyes. "This isn't just a tremor, it's something massive," she warned, her voice trembling with a mix of fear and awe. As the day progressed, the tremors grew stronger, shaking the lab and rattling the windows. The team worked frantically, trying to understand the scale of the impending event. Authorities in Texas and neighboring New Mexico were quickly alerted, as the seismic activity was spreading across state lines, creating ripples of concern. By midday, the ground quaked with a ferocity that was both captivating and terrifying. The sky darkened, and the very earth seemed to convulse. Evacuation orders were issued for the entire region, with citizens in both Texas and New Mexico hurriedly gathering their belongings and fleeing to safety. In the aftermath, as the dust settled and the once bustling towns lay eerily quiet, the scientists could only reflect on the extraordinary chain of events. Their research had inadvertently become the stuff of legend. The record would forever be known as the day when scientists evacuated Texas after the strongest earthquake ever hit Texas, boosting safety and infrastructure. Looking ahead, there's growing excitement around diving deeper into research to uncover the effects of the recent earthquake in Texas and other regions like it. There are several important aspects to consider. For starters, there's the issue of infrastructure. Since earthquakes aren't a common concern in West Texas, many of the buildings and structures aren't built to handle big quakes. This recent earthquake serves as a wake-up call to check the strength of the roads, bridges, and buildings. It also highlights the need for public awareness, especially for those who aren't familiar with earthquake safety. This event likely increased local awareness about earthquake preparedness, emphasizing the importance of having a plan in place. Simple steps like creating a family emergency plan and securing heavy items in your home can make a big difference in keeping everyone safe during an earthquake. The 2015 earthquake near Dallas-Fort Worth, for example, left visible damage and underscored the urgent need for improved earthquake readiness in the area. Insurance can cover earthquake damage, but the rising number of claims has alarmed both homeowners and insurance companies. The psychological toll is also noteworthy. Many residents who had never felt an earthquake before are now living with the fear of potential seismic events. This fear has led to increased anxiety, especially among those who have experienced multiple quakes in a short span. Economically, the situation is challenging too, particularly in areas where the oil and gas industry is crucial. While this industry is a major source of jobs and revenue, earthquakes pose risks to vital infrastructure like pipelines, roads, and buildings. The cost of repairing earthquake damage and upgrading infrastructure to handle seismic activity can be hefty, adding another layer of concern to the mix. In response to the rising number of earthquakes, Texas has been taking significant actions to tackle the issue and lessen the risks. Both state and federal agencies are involved, working hand in hand with the oil and gas industry. Texas Railroad Commission, RRC, which oversees the oil and gas industry, has introduced new measures to lower the chances of earthquakes caused by human activities. These measures include stricter rules on how wastewater is injected underground. The RRC has set limits on the volume and pressure of these injections and requires operators to keep a close eye on seismic activity near disposal wells. When necessary, the RRC has ordered some disposal wells to be shut down or closed if they are linked to earthquakes. These steps have been taken in response to specific quakes or clusters of quakes in areas with many disposal wells. Research is still ongoing to understand the causes of earthquakes in Texas and to develop better strategies to prevent them. Texas has expanded its seismic monitoring networks, working with state agencies and universities to get a clearer picture of earthquake risks and pinpoint areas where more action is needed. Researchers are also exploring new ways to handle wastewater and develop technologies that could reduce the amount of wastewater produced during oil and gas extraction. A comparative study. When we think about earthquakes in the United States, California is usually the first place that pops into our heads. Known for its frequent shaking due to its spot along the Pacific Ring of Fire, California sees hundreds of earthquakes every year, some of which can be truly destructive. But recently, Texas has been in the spotlight for a different reason, a series of back-to-back earthquakes. Unlike California, Texas isn't known for major seismic activity, making these recent events particularly surprising. California has a long history of earthquakes and has built a strong system to handle them. The state has some of the toughest building codes in the world, designed to ensure structures can handle strong shaking. Plus, Californians are used to living with earthquakes, so they're generally more prepared and know how to react. However, there's still much more to learn about this phenomenon. On the other hand, Texas usually doesn't experience many earthquakes. Its geology is quite different from California's, because it's located far from the tectonic plate boundaries where most quakes happen. So, when Texas does have an earthquake, it often catches people off guard. Recently, Texas felt a 3.1 magnitude earthquake, followed by 2 aftershocks, with the possibility of more to come. The state's infrastructure isn't built to withstand strong earthquakes, so even a quake of this size can cause significant damage. In California, a 5.1 magnitude quake might cause only minor damage and be quickly forgotten, but the same quake in Texas could have more serious consequences. This difference is not just about the buildings, but also the public's readiness. Californians are educated about earthquake safety from a young age and regularly practice drills, while such preparedness is less common in Texas, making it harder for residents to know how to respond effectively when the ground starts shaking. California's unique geological setup makes it a hotspot for frequent and sometimes intense earthquakes. One key player in this seismic activity is the San Andreas Fault. This major fault line acts as a boundary between 2 huge pieces of Earth's crust, the Pacific Plate and the North American Plate. It's infamous for causing some of the most significant quakes in U.S. history, like the devastating 1906 San Francisco earthquake. In contrast, Texas doesn't have major fault lines like California, which is why big earthquakes are quite rare there. To understand the Texas earthquake in a global context, It helps to look at worldwide earthquake patterns. Earthquakes are a common occurrence across the globe, with thousands happening each year. While most of these are minor and go unnoticed, the larger ones can cause severe damage and loss of life. The most active earthquake zones are found where tectonic plates meet. The Pacific Ring of Fire, a vast area that circles the Pacific Ocean, is the most active seismic and volcanic region on Earth. Countries like Japan, Indonesia, Chile, and New Zealand, which lie along this ring, frequently experience powerful earthquakes. Lately, we've seen a rise in major earthquakes around the world. Some scientists believe this is due to natural cycles of the Earth's tectonic activity. Others are investigating whether human actions, like mining, the creation of large reservoirs, and hydraulic fracturing, could be playing a role. The recent earthquake in Texas fits into this pattern of increasing seismic activity in places not usually known for such events. This raises questions about whether other regions might experience similar tremors in the future. The Earth's plates, which are like giant jigsaw pieces floating on molten rock, cause earthquakes when they move and collide. Imagine these plates as huge tubes in a river that bump into each other. When they grind against each other, they build up stress along fault lines. This stress eventually gets released as an earthquake. The strength and frequency of earthquakes in a region depend on how quickly the plates move, the area's geological features, and the presence of fault lines. For instance, in California, where the Pacific and North American plates are constantly pushing against each other, earthquakes are quite common. On the other hand, Texas, far from these active boundaries, has fewer natural earthquakes. But now, human activities are adding a new twist to Texas's seismic activity. Looking at the Texas quake in a global context offers some intriguing insights. While the quake was quite noteworthy for Texas, it would be considered modest in places like Japan or Chile, where such quakes are more frequent. This comparison highlights the need for robust earthquake preparedness and infrastructure. Countries like Japan have invested heavily in quake-resistant buildings and early warning systems, which help minimize the damage even from large earthquakes. The Texas quake also brings attention to the growing issue of human-induced earthquakes. As we push into once stable areas, the chances of triggering earthquakes through activities like fracking are increasing. This isn't just a US problem. Countries like Canada, the UK, and China are also reporting similar issues related to industrial activities. How do you think Texas should prepare for future earthquakes? And what steps do you believe are most crucial for keeping communities safe? Let us know your thoughts in the comments.